Jim Lawson began his career in the educational system by instructing the Mechatronics program for Southern Tech in Ardmore. Mechatronics is a specialized industrial technology program for high school students and young adults. Computer programming, industrial maintenance, computer technology, mechanical and electrical technology, and other manufacturing and industrial specialties are included in the program. Mr. Lawson joined the Oklahoma Manufacturing Alliance as a manufacturing extension agent and continued his career with the educational system. Once working in this role, Mr. Lawson transitioned into an industrial coordinator at Pontotoc Technology Center in Ada, where he is still employed and provides expertise in the heavy industrial and manufacturing sector for that school. Mr. Lawson's background includes automation engineering, project engineering, plant engineering, and project management for some of the largest companies in the U.S. and the federal government. Woo, Jim! He is a graduate of Oklahoma State University. Feel free to clap on screen or whatever you need for OSU. Please welcome Jim Lawson.
Well, thank you, and I appreciate all the good words there. I did work for General Motors. I worked for the FAA as a contractor and worked for the Department of Defense as a contractor as well. So have some background in some of this stuff. So I've also worked for some small companies and even ran my own small company, a couple of different avenues. So I don't claim to be an expert necessarily on the topic of Tinkercad, which is what we're going to discuss today, but it's going to be a really good tool for all of you to use in your classroom. And you can use this tool with young kids all the way up through. I mean, currently I will still get on Tinkercad from time to time when I have a simple design to do, because it's so fast, so quick, so easy to just jump in there and get this done. Also, I find that it's really good for kids because it's quick to get results. And I think you're going to see that today. We got a couple of different ways to look at this, but I think the best way for us to do it and what you can expect out of today is we're going to all build a login, create a Tinkercad account. We're going to go through some of the tools and how to build devices and drawings and 3D models. And then we're going to look at what that means in a 3D printing world as well. So I guess I probably need to share my screen, and we'll start with a little bit of a presentation about engineering, okay, and why we need it. Realize that one of the things that we do here in Pontotoc County is we have a career discovery day that begins in the 8th grade for all students in Pontotoc County. And that's a very unique program. It starts in the 8th grade, and we have a day that they all get together and they get a chance to talk with and hear presentations about different career paths. And I mean, it's a lot of kids, and they get about 45 minutes per type and activity. And I usually speak about either manufacturing or about engineering with that group, sometimes about robotics and the automation area. But I've been a part of that for almost every year they've had it, and it's been going on about, gosh, I want to say, Jenny might be able to tell me, I'm going to say since about 12, something like that. But we also do it in the 9th grade. We have an activity, the 10th, 11th, and 12th. And through that career discovery day, those kids are really exposed to a lot of different careers that they might not normally be exposed to. What we've found is that a lot of times kids, unless they know someone or unless one of their family members happens to be an engineer, they don't even know what an engineer does. And I would venture to say that that goes all the way up through a lot of parents who don't necessarily know what an engineer does. They hear about them, but they don't always know what they actually do, especially on a day-to-day basis. So I'm going to share with you a modified presentation that I would do with them, and hopefully you guys enjoy it as well. And again, I want to thank the people at Career Tech for putting this all together to be able to do this by Zoom. It's a really great technology, and it shows again the advantages of Career Tech and their flexibility and their ability to adjust and customize training. And certainly we do that on a daily basis at Career Tech. If you aren't associated with your Career Tech as an instructor, you need to find someone at your Career Tech that does that you can talk to and that you can become a part of what's going on there. It's a great resource. So here we go.
Thank you, Jim. That was nice of you to say.
Okay, engineering as a career is our topic. Why do we need engineers? This is one of the things that we get asked a lot. Well, engineers are there to solve problems, increase productivity, sales, and basically improve the economics of a company. Engineers push existing technology. They always are looking for the next new best thing. And they ask a lot of questions and move the technologies that we currently have forward. Some of the qualities that you should look for in your engineering students or your potential engineering students. Are they an analytical problem solver? In other words, do they like math and science, and do they like puzzles? I mean, in the younger kids, a lot of times you can find that your analytical problem solvers are people who love puzzles and love games, word games, number games. Are they organized? An engineer, generally speaking, is a really organized person. They like things in neat little boxes. Are they detail oriented? In the engineering world, your detail is your success. Without a lot of detail in the game, you're really struggling to make sure that certain things happen that have to happen in the engineering world. So we definitely want detail-oriented people in that game. And again, here I'm talking about general qualities of overall engineering. Specific types of engineers require different skills, of course, and certain characteristics that are better than others. Also, I would tell you guys, everybody, if you have a question or anything like that, pop it in the chat box, and the people that are monitoring the deal will make sure that I get that, okay? And if you need to stop me, speak up, because if you have a question, we'll kind of do this a little bit interactive if we can. Cost conscious is a quality that may have to be learned down the road, but engineers possess that in most cases. They almost always are operating under a restraint of some type of budget. Outside the box, that's such an overused term, but the gist of that means that you have to really be creative and don't just respond to what the answer that the people that think they know what they want really, they may or may not know exactly what they want. You have to really get into the problems and figure out what it is that's going to solve the problem. So sometimes you have to ask questions that seem very odd, but yet that helps fuel the fire to solving the problem. Creativity is huge. And one of the things that you have to really be careful about with creativity is that you still have to be able to do it, but at the same time, you have to be creative enough to not be limited by the current technology that's out there. So that's a really difficult thing as an engineer. In a lot of cases, they almost train a lot of the creativity out of you because they want you to do things in a detailed, cost-conscious, analytical way, but yet we still have to maintain a lot of that creativity. Also, you have to be very inquisitive. Asking why and how does that work? Why does it work that way? That's a huge issue toward developing your young students into engineers. And again, here, I think on this call, we have everybody from kindergarten to 12th grade and beyond. Am I correct there, I believe? So we're liable to have people with elementary students, and believe it or not, you can start developing these engineering skills in them through the STEM efforts. How do you prepare students for an engineering career? That's what we were just talking about. Math and science, computer classes, these are skills that engineers possess in pretty high regard. A lot of times, one of the things that I would try to do in some of the programs that I've taught is teach math where they don't know that they are actually learning math. That is so key, especially to kids that are really good at with their hands. They think they're not that good at math, or they're not that good at science. So we have to kind of find creative ways, different ways to do those kind of trainings without actually setting them down and saying, here's the problem, 1 + 2. We find other ways to do that. That's huge for them. Math, of course, used extensively, like I say, with the kids. All right, so I'm going to just stop right there for just a second because I see the chat starting to fill up with some stuff here. So we're going to answer a couple of these questions before we get too far along. Some of the people are already using Tinkercad and MakerBots to do some of this, and I appreciate that. Tinkercad is a great resource. I agree with that. Let's see. Yeah, 5th to 8th grade, not a problem there. We do sometimes like in Tinkercad, as far as that goes, for the kids to be 13 and above, you can get a provisional login below that. So Gina put in there what the OEIP system is all about. So, for example, engaging a panel of employers through Zoom meetings, some of that kind of thing. So, again, if you get a chance, look in that chat and you'll see some of that, what's going on there. Okay, so back to our presentation, which math, like I say, extensively used by engineers, and try to teach your math to your younger kids that think they can't necessarily or aren't that good at math in a way that makes them not realize they're doing math. One of the things we do is we have a game, and it's the ruler game, and you can play it online. You can look it up sometime, or we can put it in the chat. Get that information to you. But the ruler game is a fun game. Steve, who's also on the call, he and I use that game a lot in our classes with high school students, and would have races to see who could solve the most problems in a certain amount of time, all this kind of thing. And it's really all about using a tape measure and using fractions, but the kids don't realize that they're actually learning all this math. It's a fun game. So let's see here. For some reason, I've lost there it is. Science, of course, and physics. Science and physics is the background for all of engineering. It is what you do as an engineer every day, is you're using math to solve science and physics problems. Computers are one of the tools that we use. But the computer is really a tool for us in most cases. Of course, there are computer engineers and programmers and hardware engineers and things like that. But again, the computer for most engineers is a tool that they're going to use, and we use it extensively. And so again, you may or may not know the types of engineers that exist. And I will say that this is not an exhaustive list of the types of engineers, but it is a good list of some of the different disciplines that they can study while they're in school. So aeronautical and aerospace engineering, that's pretty straightforward, but that's a division of a mechanical engineer. In general, those are mechanical engineers that have been specialized in aerospace or aeronautical engineering. Agricultural engineering, you think, what in the world is that all about? But they do solve a ton of problems associated with agriculture, and that is a discipline that's taught as its own, agricultural engineering. Biomedical engineering, of course, I think you can follow that path, and that is in high demand right now. A lot of people working in the medical field, in the engineering world. Chemical engineers have been around a very, very long time, and that is a dedicated discipline that, again, requires a lot of math, science, and that type of individual. So realize that again, a very high paid and high demand area. Civil engineering has to do with roads, buildings, bridges, structures, that type of thing. Again, well known, been around for a really, really long time, and a discipline that most schools are going to teach in the engineering world. And realize also that that schools are very specific. Not all colleges and universities teach engineering. So there's only a few in the state that do that. Computer engineering is a relatively new one within the last 30 to 35 years. Electronics and electrical engineering been around again a long, long time. Health and safety. This is a huge demand, extremely underutilized, underserved area, but it has to do with compliance and environmental protection, with health and safety of the individuals, OSHA compliance, government regulation, fire and safety. So this is another area, and it's a very specific type of engineering degree. Industrial engineering is also a really high demand area that requires a lot of logistics and is a really kind of a multi-use degree. Has a little bit of business, has a little bit of layout, has a little bit of scheduling, a lot of different aspects to it. Companies a lot of times will hire industrial engineers to do their worldwide planning or their worldwide scheduling because they understand a lot to do with the inner workings of a supply chain. And of course, mechanical engineering, I think we all can understand what a mechanical engineer does. Geological, of course, they're going to work a lot in the oil and gas industry, and they can be, in Oklahoma, extremely well paid and extremely high demand. Nuclear engineering, very few programs around have a specialty in nuclear engineering, although that's going to be an advanced degree area that engineers are going to take on. Petroleum engineering, again, high demand in the states that are oil producers, Oklahoma, Texas, Alaska, etc. Kind of education are we looking at for engineers? Well, it depends on how deep you want to go with engineering. There are 2-year associate degrees, there are 4-year bachelor's degrees, master's degrees, and doctorate degrees. So these degrees come at a point where it all depends on the outcome that you're looking for. A lot of times a 2-year degree might be a drafting person or a designer. A 4-year degree might be an actual engineer. And then a master's degree might also add a business component to it, or they might even go deeper into the actual engineering and science side of things. This business administration or a master's in an MBA paired with an engineering degree is a really positive thing, especially for people who want to move up a corporate ladder. A lot of times they'll enter a company as an engineer, but with that MBA, they're able to move into the management role and move really high up in those companies. What should your students ask of themselves? These are just a few questions that I like to throw out there. Do you like to solve problems? Do you wonder why and how things work? Do you like things that are challenging? How persistent are you? Enjoy learning new things? Apply what you know? Create new things? Do you like the details of a project? Those are all things that we would want to have our students ask themselves, especially if they're really getting close to going into an engineering program at college or wanting to really go down that path. Parents often want to know what's the outcome of this engineering degree. Are they going to make enough money? What kind of money are they really going to make? I think there are a lot of numbers that are thrown around out there these days that might lead you to think that engineers are rich and make tons of money and all this kind of thing. Well, they do make good wages. There's no doubt about that. But that doesn't mean that they're really just over the top and that every corner you can get a job. That's not really necessarily the case. A lot of times engineers will have to relocate to an area that supports the kind of engineering that they're wanting to do. So, and for example here, this was taken from a Bureau of Labor table. About $68,000 a year is what you could expect out of a couple of years of experience with an agricultural engineer. And then petroleum engineers, depending on the current market, can make up to over $100,000 a year with just a couple of years of experience. And that's all going to depend on the demand. And then the other engineering categories fall somewhere in between. And so one of the questions is, why do we want to study CAD or modeling to support engineering? Well, CAD or computer-aided design and drafting is the foundation for building parts and buildings, and it's what we use in the current technology. I can tell you that when I went to school, which is a long time ago, I learned basically on a drafting table, and we did our design work by pen and paper. We, in my senior year, were finally able to do CAD work. But the CAD work that we were able to do, I had to program every line one by one. So it wasn't a true CAD that you would think of today. Shortly thereafter was the introduction of a program called AutoCAD and the introduction of large computer-aided drafting machines that large companies had, but realized that people my age and younger have now grown up with CAD, but CAD was not always around, that's for sure. So now we've got it, and we've got 3D modeling that is the next generation of CAD. And now we're even to the point of using Tinkercad, which is an online program that I can teach young kids and you can teach young kids to use. Think how far we've come. We've really come a long way, and we've got a great amount of resources at our fingertips with this kind of technology. We just didn't have that. And it was very hard to do drawings and very hard to do really complex things. It took a lot of people. So one of the things that I really do enjoy about the engineering world is there's a lot of colorful characters out there, and Henry Ford was one of them. And why do we need creative people? Well, this is one of Henry Ford's quotes that I like. If I'd asked people what they wanted, they would have told me faster horses. Instead, he said, what do we really want? We want a car, something that we don't have to feed and keep going. So he was a very interesting character and did a lot of things in the engineering world that no one even thought of until except for him. So he's one of my role models, I guess is what I would say, as far as, or one of my heroes is probably more like it. So I'm gonna hit the chat box here. Let's see what we have. Ruler game sounds fun. That's true. It is. It's a really good learning tool. Thanks, Steve, for putting that attachment or that in the chat box. I appreciate you sharing that. Nuclear engineering, Navy recruiters. Of course, that's a great thing for you to put in there, and thank you, Ms. Poole, for putting that in the chat box as well. Again, I want this thing to be as interactive as we can. I think there's a ton to be learned from this group. If you're willing to sit through this for a couple of hours, then share what you know in the chat box, and we'll all learn something from it, and certainly appreciate that. Okay, so let me get off of this. Let's see here. There we go. So I would say at this point, let's one of the things I'd asked for, and I hope everybody was able to do it. If you're not, it's fine. You can follow me, and I will do it. But if you'll bring up your Google or whatever browser you use and type in tinkercad.com. My system's not going to let me show you the very first screen you're going to get, so we're going to let you do that. Is my screen still sharing?
Yes, it is.
Okay, good. Thank you. I've got a message that says your screen share is paused. So.
It's showing on the PowerPoint. So if you're needing to share a different screen, you'll have to stop share and then reselect that.
Okay, so we're going to stop share, and then we're going to share again a new screen. So I would ask everybody to go to your browser, or wait a minute, let me do this. Anybody have any questions about engineering? I'd love to answer them. And this is probably the time to do that. If you've got a question, throw it in that chat box. I'll try to answer it for you. Okay, so I'm gonna assume that we're good on questions, and I hope you found that to provide you with some information. So we're going to share my screen again. One of the things, let's see where. Here we go. Okay. Everybody see my Tinkercad screen, I hope.
Yes, we can see it, Jim.
Okay, thank you very much, Kara. So if you'll type in tinkercad.com, which is up here in this left corner, it's probably gonna ask you to sign in or create an account or do something like that in the upper right-hand corner. If you would take just a minute and create yourself a Tinkercad account. You'll have to have an email address is the way I would suggest you do it, and then put a password in there. It's a free account, and it's all web-based, so you can get this anywhere with your login and your password. Give you just a couple of minutes to get that done. A lot of times when I'm teaching this particular class to my room full of students, it takes a few minutes, but we will, there's two ways, and I'll go through that here in a little bit, but generally I don't pre-register them. I will get them to make their own account on the spot and with an email address, and then they have access to it, and I don't need to know all about their logins and all that kind of thing. So once you're in, you can just kind of follow along with me for a few minutes. This is what I will do is, my plan is that we will go through the tabs and some of the information that's available to you. And as time allows after lunch, and by the way, Kara, what time do we do the lunch? About 30 minutes?
We will have an hour for lunch from 12 to 1.
Okay, and then we'll do 1 to 2 after lunch. Okay, good. So we've got about 30 minutes or so. So I just want to kind of make sure that you follow along here with what Tinkercad is about and the navigation of Tinkercad. Also, if you don't get your account made here right away, you can make that account during the lunch break, if that's okay. So let's start with, you'll get different things. If you go up to the top and click on the Rubik's Cube here that says Tinkercad, you're going to get something that looks somewhat like the screen that I have. Yours may not have any new designs in it. It may even ask you, do you want to create a new design? And we can do that, but let's learn about the system to start with. So here's where I'm going to go. I'm going to go up here to the right to the gallery, and I'm going to click gallery. And what that's going to show you, these are some designs that other people have done that you can peruse and see different things that other people, and you may even be able to download them and then modify them. But they're out here, and you have the ability to share designs into this platform if you so desire. Here it shows the gallery of designs. We also, the neat thing about Tinkercad that's fairly recent is the adding of the electrical circuits platform. And so this electrical circuits platform allows us to use it to actually do electrical simulation. Now, a lot of you that are in high school or junior high know what an Arduino or a Arduino Uno is, maybe even a breadboard. But this gives us an opportunity to actually build a circuit and simulate it within Tinkercad before we actually go out and plug it all in. How cool is that? I mean, that is free right here for you to be able to do a design, have a simulation program, and actually see it work. It's crazy. I mean, one of the things that Tinkercad is is a sister of Autodesk. Autodesk is AutoCAD and is Inventor. These are higher level programs that we actually use as professional and experienced engineers, okay? AutoCAD was the first, which basically was a two-dimensional world. Let me think of the name of it. Inventor was AutoCAD's version of getting into the 3D world. They tried to force 3D into their AutoCAD program, and it still will do 3D, but it is not nearly as good at it as the Autodesk version of Inventor. And then another company, a competitor of Autodesk, is called Solidworks. And Solidworks is again a really high level program that we use in engineering, and especially 3D design work. I could spend all day just talking about SolidWorks, and I won't do that. Just realize it's out there. Today, we're going to start at the bottom, and the simplest way, which Autodesk provides us with Tinkercad. We've looked at the gallery, we're looking at the circuits here, and we're looking at design works here. That's just one place to look at that. We have a blog function that we can go to as well. And in this blog function, a lot of times they're going to have different things to post up that you guys as teachers, parents, new users, contests, new features, a lot of different things in this blog. For example, here, there's an ABCs of making hand tools. Well, again, it's just a short little presentation about making hand tools using AutoCAD or using Tinkercad. So again, another free resource for you to reach out there and see some more valuable information. I'm going to skip learn and I'm going to go to teach. Most of the people on this today are teachers, and getting Tinkercad into your classroom is the challenge, right? So guess what they do? They help you manage your Tinkercad in your classroom by going to this teach icon up here and drop you into here. So in this case, you can use Google Classroom, or you can just add students through your Tinkercad Classroom. I'm going to click on that, and it's basically going to show you, well, it jumped me out. Let's go here again. Let's see what this does. Okay, here we go. So this is introducing us to Tinkercad Classrooms. You have to sign up for it if you're going to do Tinkercad Classroom. You may have another learning management system that you use. This is just one way to do it through Tinkercad. So realize that is there, and it allows you to add students and assign them a Tinkercad account, and you be able to monitor and manage their activities. Each one's gonna, if you want to put an assignment into a class, then it will give you a specific code for that class so that only your students will be able to join it. And again, it's all about you having control of what classroom and what you're doing for your student. And like I say, you may offer that through another learning management software, but this is one way that Tinkercad is going to help you get there. Okay. Back on teach here. So, and then again, like I said, Google Classrooms is there as well. Now, always a concern is, especially with kids, is making sure that parents and that the policies of Tinkercad is everybody's on the same page from a legal standpoint and from an access standpoint. So again, Tinkercad has helped provide you with some of the tools that you need in order for you to get approval from the parents, if need be, to build a Tinkercad account. So it's here, resources are here. So realize that's available if you need it. Let's see, go back to teach. Student data and privacy, that's another one. Of course, Tinkercad privacy FAQs. Here's a good one. I looked at it and it's got a lot of information here. How, and your school may even be asking if it's okay for you to use this. And in that regard, here they're saying less than 13 years old, you need some more approvals. Authorizations by parents and student and teachers. Is it safe advertisement wise? A lot of different FAQs that may come up. You can find that information right here in this little box without having to chase down everything all over the internet, find out what's going on there. Okay, back here. Also, they have some other lesson plans and development plans for you. So you don't always have to be the one that develops every ounce of curriculum that you're trying to instruct from. One of the things that I do for my 9th grade day that the kids come out here to the tech center, and I spend about 2 hours with 2 different groups, and we go through this Tinkercad, learn how to use it, and then I give them a challenge to build a phone case or a phone prop to sit on their desk. I also have done it with the aviation club here in town, and we designed airplanes while they were here on campus. We even went as far on that one to 3D printing some of the airplanes that they designed while they were in class. And so in a couple of hours, you can put together a lesson that is really a lot of fun, and it expands some of the knowledge that the kids have. And they're learning math, they're learning science, they're learning the design skills without even realizing it. They're basically playing a video game, they think. And so that's a really fun thing about Tinkercad, is that you're learning those skills. And what they do is they learn by making mistakes. And I want them to make a lot of mistakes, because I think that's what really is cool about Tinkercad, is you can make a mistake, but it's not gonna hurt anything. You can make that mistake and back up and go back to where you started. All right. So, like I said, here's some lesson plans that Tinkercad has. This hour of code is kind of one of the fun things that I've seen in this. And I don't know if y'all have visited this instructables.com. I haven't actually visited it till I looked at this, and I found it to be interesting that some of the more sophisticated designs, they're teaching you how to do those. So that was pretty fun to do and fun to look at, and something that you could do in your classroom. So go back another notch here. Let's see what this guy has here. Yeah, this was another one of these deals where the lesson plans are made for you. Let's click on this balloon car. It's the first one in place here. There we go. So it already has the design work, or at least the layout for you, the lesson overview, and how it's going to teach your students the design process. Okay. and realize that eventually we're going to be trying to teach these students who are learning the skill of Tinkercad. Also, we're going to want to teach them the design process, from brainstorming, identifying the problem, exploring what's out there, creating some new designs, etc. These are all standard design characteristics and standard design criteria about how you get to the end result of a finished product, and one that's usable and solves a problem, for your audience, whoever you define that to be. But here's a whole lesson based on this. All right. So anyway, this is a neat little project and a neat little thing to consider doing, even to the point of, if you've got access to a 3D printer, printing out the design that they come up with, putting it together, and then maybe even having some races. So that's a fun thing to do, and we do that with some of our engineering, after-school engineering programs in our county. Several other designs here. This one I found to be a really unique design. So let's go in, let's say your kids you want to talk a little bit more about electrical engineering and circuit boards. This is probably the simplest circuit you can make, but they're learning how much more complicated things are than at first glance. This basically is a piece of cardboard with some paper clips and a list of identifying things. So if you're saying, show me which is the hub, and you take this probe and you touch this, that light will light on. They can build this. So that's a really cool little project to build. But if you don't know what you're doing, it looks complicated. So this particular deal really doesn't have a lot to do in Tinkercad, except that it has a lot to do with circuit design. And doing that exercise, you could easily do a Tinkercad circuit design using this information, and instruct the kids on the fact that here's the output. Now, how do we get the design so that we could actually make this? Just another neat way and a backward way of doing a design like that. Okay, so several different ones here. We saw a design that was a graphic or a part design, and then when I showed you one that's a circuit design. So, and there are several others here. So, learn 3D printing. I really can't separate the design side of things and the 3D printing side of things. We have a lot of people ask a lot about 3D printing, but they forget the entire design process. It's a huge part. It actually is the fundamental part of 3D printing. So again, why are we talking about Tinkercad today? So that we can also talk about 3D printing. Got to get the cart before we get the horse, right? All right, so that's, again, 3D printing is the end result of good design. If we don't do a good design, our 3D printing is useless. So what 3D printing does for us, though, is give us a tangible part in a short amount of time based on the design, the 3D modeling that we've done. So that's a pretty cool thing. All right, let's see here. Let me just look in the chat real quick. Okay. Appreciate what everybody's putting in there. Yep, you can use this. You can use this in any level of classroom. Does Tinkercad hook up to a 3D printer? Okay, that's a perfect question, because here's the deal, and that was from Michelle. Without a design, your 3D printer can't do anything. So you either have to get a design that someone else has done, or get your design, save it in what's called an .stl, Sam, Tom, Lima, STL file. And then your 3D printer will take that STL file, slice it into thousands of segments, and allow the 3D printer to work. We'll cover a little bit more about 3D printing a little bit later today, but I want to answer that question so it doesn't get lost. All right. Let's see what else we have. So from Steve, you got a assignment in our LMS to verify completion of creating any third-party account, such as Tinkercad SolidWorks. They insert a screenshot. They have created an account and get a 10 points. This provides me a checklist that everyone on board. Yeah, it's a good point, Steve. Yeah, that's a great way. So this is a way for his students to go in, create an account, and show him that they have access to this 3D modeling software. So really good there. Appreciate that. Okay, so I see Michelle, you've created your account. I hope others have created their account. If not, you can always do that during your lunch break, like I said before. Okay, so this was in this teach function is where we went to get all of this information. So let's look at this learn function right here. In this learn function, we've got starter lessons, lessons, and projects. Okay, so one of the things we're going to do here today is we're going to go over some of these very simple tasks. And I say simple because they're the elements, the elementary movements that we have to understand before we can actually build something that's usable and build a design. So we're going to do that here in just a minute, but we have starter lessons, we have other lessons, and we have projects. Another thing you can do here is if you click over here on the Rubik's Cube, you're going to see that you've just gone into what your designs are. This is my account. I've got a whole bunch of designs here. But it also shows you here that you can go into the circuits. Here we're in 3D designs. We can drop into circuits. Here are some of the circuit designs that I've done, or I've used anyway. Code blocks, I am new to code blocks, so I'm going to say I've done a little bit of research on it. It is a tool that if you do the same thing a lot, it lets you stack those up, and you can then just kind of click one thing and it'll do all those functions for you. So that will be something that I'm going to leave up to y'all to go and learn more about, because honestly, I haven't learned much about it yet. Lessons are additional lessons that are out there for us to do to learn more about Tinkercad and how to do things better. Also, online, there's just a ton of information from other users, but I do recommend, and we're going to do it today, so all of you are going to get a chance to go through these starter lessons. We're only about 7 minutes away from lunch, and I'm going to go ahead and start because I want us to get where we can do something after lunch, okay? So click on, if you have it up, if not, follow along if you're on your phone or whatever, however you're doing it. Click on the icon, the learn icon up here in the upper right, and let's click starters. And then we're going to click this deal called place it. it's going to bring up our builds area. Okay, so we are now operating in a three-dimensional space. Okay, so we're, as you can see here, we're in a three-dimensional space and plane. Now you say, first thing out of the box, you're saying, Jim's already doing stuff and I don't know what he's doing. Right click on your mouse and hold it. Bingo, you're moving it around. I'm going to tell you that this program will frustrate you beyond belief because you'll click buttons and all of a sudden things will happen and you don't know what the heck you just did. And I'm telling you that from experience, okay? It will frustrate you. The next thing I'm going to teach you is put your shift key down, push your right button, and guess what? We can move up and down, okay? Those are two functions that you just about can't do this deal unless you got that down, all right? Right click, you get to rotate the plane, do whatever you want to do with it. Shift key and right click, you can pan up and down or you can move up and down, okay? Now, next up, oh, he's zooming in now. Here we go. So this zoom in thing is, guess what? The wheel on your mouse, okay? You're going to use these things. You got to be pretty good with a mouse to do this stuff, okay? I think most of us have those skills or can easily obtain them. So those are a couple of ways to manipulate your drawing surface, but guess what? All you got to do over here, I want to see the front. There's the front. I want to see the top. There's the top, the back, the side, the other side, and we're back to the front. We can also just hit home and it goes back. Did everybody kind of follow along? I hope so. All I'm doing is clicking on the box and on the buttons here below on the left of the screen. Let's just start with that as manipulating this plane, this platform. And so what you have here, the best way I know to explain it to you, click this front. This guy right here where my cursor is ground level or my desktop, okay? When I click front, I'm talking about the one that's facing me in the beginning of my drawing. When I hit home, it's going to go back to this angled, isometric, from the front work plane view. Okay, a couple of other things on this screen without actually getting into our lesson is this. Notice this down here in the lower right corner. It says Snap Grid. Basically what that says is that your accuracy of this block is only going to be able to be 1 millimeter plus or minus. You can click this little arrow and change that to a much smaller number. The problem is if you change it to this really, really small number and you're working on a drawing that's 8 inches across, it's hard to get this accuracy with your mouse and all of that. So let's click that snap grid to be 0.25, okay? And again, I'm going to tell you that in engineering and that kind of thing, the metric system rules, okay? Everybody always, back in the days of most of us learning, we had to learn the English standard, and then we also had to learn metric system. In engineering, we live off metric, okay? It's just so much easier to calculate and do the things that we need to do. So with that in mind, teach your kids metric system and drill it. It really is what needs to happen for the engineering world. Okay, So now we have a snap grid. And in other words, a snap grid means my cursor only has to get within 0.25 millimeters of where I want it to be, and it's going to snap over to the closest 0.25 millimeters, quarter millimeter. So that's where we're at there. Again, a couple of tools that I'm just going to review you real quick. Whoops, we got a whole bunch in the chat, so we're going to stop there. Okay, let's see here. Don't forget the grant opportunities available for, one is for technology, 8 hours of attendance and OEIP. Thank you, Whitney. Donna says she's purchased a class through Amazon, very reasonably priced. Okay. My dentist shows my teeth on his screen 3D. Wonder if this is how crowns are made today. Actually, yes. Believe it or not, the technology is there. I'm not going to tell you that every crown is made that way, but they have that technology to actually scan your teeth and make crowns, and they fit. It's very, very cool and interesting. Yeah, you'll have to purchase some mice for your kids, and I think that's where this Amazon deal came from. Believe it or not, Donna, I also purchased from Amazon mice for my lab, so that's exactly right. Let's see what else we got here. How far up do we need to go here? Yeah, the last one I think we answered was the 3D printing one. Are there copyright issues, concerns, designs found online? Generally speaking, I can only speak in general terms on that one. Generally speaking, if you can download it in an STL file, then somebody has released that. Designs a lot of times are saved in PDF or in some other extension, but you can't do anything with them. So they don't release them then at that point. If the design is accessible, Steve is answering that, and then it is public domain, right? Can't wait to go home tonight and play with this with my 9-year-old son. He's been telling us since he was 3 that he will be an engineer when he grows up. That's a cool kid. I like that. Back in the old days, my parents bought me an erector set, and some of us may remember those. They were a bunch of little brackets and a bunch of screws and nuts, and I mean there were thousands of them. So that was a lot of fun. And so this honestly can be your kid's erector set right here. So that's a cool thing. Tinker Toys was that before also. Right. Okay, so a whole bunch of stuff there. And yes, you will need mice in some access. It doesn't take a powerful computer by any means to run Tinkercad. I'm fairly sure that you can run your Tinkercad if you have Chromebooks. Okay, so that shouldn't be a problem.
This seems like a good stopping place for lunch.
Yeah, I think it is. I think it is. After lunch, we will go over a lot of these tools and and if anybody hasn't gotten their account up, hopefully you can get that up during your lunch break. And I will see you guys, and Kara, you take it from here.
Sure. Thank you, Jim. A huge thank you for sharing the first half of this great information with us. It was very interesting, and I'm looking forward to part 2. Before we break for lunch today, let's do a drawing.